All right, CNT140, we're working on Chapter 4. We're on the section now where we're going to talk about routers and how they function, which is going to lead us into routing protocols and that sort of thing. So there is a connection here. So first off, I remind you, this is kind of your homeowner routers here. All right. Here are some commercial routers. These kind of deals here. This is another homeowner router here, but some commercial routers here. All right, their main job is to join two or more networks and actually move traffic, move packets, move data packets from network to network. And these could be two different Ethernet networks, but a lot of times it's usually Ethernet and some other network. Oftentimes like a LAN to WAN kind of thing. Or if you think of at home, your Ethernet LAN at home to your ISP network or WAN network. Okay, these are oftentimes connecting different transmission speeds and maybe even protocols too. But most things right now are like Ethernet, TCP/IP kind of thing on my LAN connecting to a WAN technology. That's oftentimes what's going on with the routers. They're really responsible for determining the next network in which that data packet needs to go to. So if you think back to what we said before, if you think about the IP packet as it's moving through the network, routers are going to read the IP packet, and the job of a router is really to pass it through a series of routers or networks till it gets to the correct network here. Once the router passes it in here, its job is done. So now the switch is going to read the Ethernet header, the MAC address, to get it to the correct computer. This computer as opposed to this computer kind of thing. So really the router is there just to get it to the correct network. I keep using the example of hack. Something comes from the internet or ISP. The hack's router's job is really to get it to, the Harrisburg network as opposed to the Lancaster network. Once it does that, it's the job of the switch at that network to get it to the correct workstation at that network. Okay, that's really your job of the router. The router itself does have, it kind of reminds you of like a computer that's been stripped down for the function of moving data packets. So it does have a processor, it does have a router operating system, it does have memory, it does have input and output jacks for different types of networks, and usually a management console interface. But it doesn't have the usual monitor, keyboard, mouse ports that you would have on a computer. So it's really just kind of like your computer with those, monitor, keyboard, mouse kind of thing pulled away and a few extra network ports for different types of network connections. So here is just a sample. If I tear apart a router, this is the kind of thing I find. I do have the main processor chip. I have some LAN ports. I have some WAN ports. I do have some ROM. I do have some RAM. Okay. So it kind of looks like a specialized computer, that's what it really is. Side note, you can actually take an old computer, put a couple NICs in, and load on an operating system like ViOS, used to be Viata, and that will actually turn it into a router. So router really is just a specialized computer with a couple of network ports in, if you will. That's really all it is. Here is a router that looks very similar to the kind we use in our lab room. This is a good industrial, commercial grade remote access, a branch office router kind of thing. And here are a couple LAN ports on, just a couple, and there's a bunch of WAN slots, and I can put in different cards here for connecting to different ISP type connections. On the back are the console ports for connecting in and configuring it. Again, here's a bunch of different commercial grade routers that you would have. All routers do these tasks, and they also do a few optional tasks. Well, let's hit the things that they all do. They do connect to similar networks, LANs to WANs. Yep. They often read layer 3 addressing, IP, and sometimes even layer 4 addressing like TCP port numbers, passing traffic or filtering traffic. They're going to determine the best path from A to B, so it's going to consult its routing table to say, well, this should be the best way to get there. Kind of like you do in your brain when you're going to drive somewhere, you go, this is probably the best way to get there because it's very busy on traffic right now. And routers also have the capability to reroute traffic if that main path is down and it knows another path, it'll try to route around that traffic congestion, and or if that network is broken. Routers can perform some optional functions, filtering broadcast traffic, acting as a simple firewall. Again, writing some rules on to filter or pass traffic. Allow local and remote connectivity, SSH and that sort of thing. Provide fault tolerance. It could actually have redundant operating systems in, redundant power supplies, that sort of thing. Monitor network traffic and report statistics if I'm doing like network management. Diagnose some internal connectivity problems and trigger alarms. Again, if I have it configured to do network management, SNMP protocol, if you will. Routers can be categorized by their function, core or interior routers. The core or interior routers are going to direct traffic between networks within the same autonomous system. Okay, routers at maybe Harrisburg, Lancaster, Lebanon, York of Hack. Those routers connected together are going to pass traffic between our campuses. Meanwhile, an edge or border router, this guy here, would be the one that's designed to connect out to the ISP or ISP connection, if you will. Exterior routers, these would be ones that your ISP has to route traffic from provider from customer to customer, if you will. We'll put it that way. These are the ones that act as the internet backbone. Your homeowner routers are often like plug and go. You pretty much plug it in and let it boot up, and you might browse in and do a couple little changes on it. And again, I'm going to browse in. I'll use my browser and click a couple buttons and change some settings on it. But the kind of routers you have in a business are these guys in here that actually require you to console in. You actually need to use a separate connection and console in and run a whole series of commands to configure it for functionality. A lot more administratively involved to do this. And here's a sample configuration for one of our lab routers. This is actually a relatively simple configuration, but you get the idea. Almost every line here you had to type some kind of command to make that appear. I need to configure the interfaces. I need to configure my routing protocol to get this thing to work and pass traffic from network part to network part. That is actually what needs to get done. Now, while they're talking routers, they say, okay, multi-layer switches occur too. And this is a good time to talk about them. There are such a thing as a layer 3 and a layer 4 switch. A layer 3 switch, okay, let's back up and say layer 2 switch. A layer 2 switch that we have already learned about. Layer 2 switch is designed to read MAC addresses and make decisions based on MAC addresses, layer 2 addresses. It cannot do anything really more than that. Your router is the one that's typically designed to deal with layer 3 or IP addressing. But one of the problems with the router is it adds latency. It takes time for it to make all of its decisions to move traffic through the network. So, a layer 3 switch is a switch that can actually read layer 3 addressing, like an IP. So it can actually read and pass data very much like a router. But it's going to do it a lot quicker than a router. As I like to say, it's going to have some smarts of a router, but some speed of a switch. So it's trying to combine the best of both worlds there. The main difference is the hardware and how it's built to do that. How it's inside the guts, if you will, is designed to read the IP and move it through quicker. So you have some advantages of a layer 3 switch because it has some intelligence of reading the IP address, but it does not have the level of smarts a router does. So it's kind of sitting in between a switch and a router. It's smarter than a switch, a layer 2 switch. It's able to do more than a layer 2 switch, but it doesn't have all the features of a router. So it kind of sits in the middle. All right, and I'm going to get to an example of it here in just a minute. And they also do make layer 4 switches too, which can read layer 4 data, which is your TCP UDP port numbers, also called application switches. Well, where these come into play is an example I'm going to show you here in just a second. Okay. Now, how do we know the difference? I pulled up a sample layer 2 switch off the Cisco site, and here's one of their 48-port layer 2 switches. If I look down through the model numbers, here's the model numbers, and they tell you over here in the feature set that this is a LAN base. That's your layer 2 switch. That's their code phrase for layer 2 switch. If I look at one of their other models, here's the X, and then here's the XR series, okay? The XR series, as I look at these model numbers, I see it's an IP Lite. It's a layer 3 switch. It's able to read IP addresses and move data based on IP address. So that would be a layer 3 switch. So there's a quick example. The outside doesn't look any different. It's the kind of the operating system inside that's a little bit different. That's one of the first things you notice. You will also notice if you look up the price, these are a little bit more pricey than layer 2 switches. You get the extra feature. The advantages you get with this are It does act some broadcast control, so it has a little bit of router functionality. It is a little bit better than a switch for security. It does process data with the intelligence of a router, but at the speed of a switch. That's all good stuff, and can be the collapsed backbone part of your network. I'm going to show you what that means in just a second. The disadvantages is it is still not as good as a router, so it doesn't have the advanced security. It is more expensive than a switch, and it is not a good choice for connecting the ISP. The routers which you really need for that, or firewalls which you really need for that. Okay, when we say collapsed backbone, this is what we're talking about. All my layer 2 switches in a building, floor 3, floor 2, floor 1, if I want to combine all them to a router and out, what I can do is bring all these layer 2 switches into a layer 3 switch, combine them with some intelligence, and then move it out through the router. And the reason I might do that is the router does not have enough ports to do this. The switch would. And I could have a 4th floor, 5th floor. I could have 2 or 3 switches up here connecting, 2 or 3 switches here connecting, 2 or 3 switches here connecting. This will have enough ports to combine all of them and move that traffic to the router, not to the ISP. That's called a collapsed backbone. A layer 3 switch is a really good use for that. A collapsed backbone. Very common in network topologies. All right, that brings us to some more on routers. I am going to pause there, and I'll come back in the next one and continue on routers.